So for AP Biology, the last of my 4 portions talking about the different molecules and the patterns. So we need to talk about nucleic acids. And it's important to know here, guys, that you're going to see a lot of the same things. Nucleic acids are the biggest of the bunch. So there's 3 parts. You see a phosphate molecule, which is just phosphorus attached to 4 oxygens, a 5-carbon sugar, and there's typically 2 different 5-carbon sugars, and you're going to know them, ribose and deoxyribose, and a nitrogen base. And there's a couple different nitrogen bases. You don't need to memorize them. You're going to learn them anyway when we get to those different parts. And nucleic acids are made of carbon and hydrogen, oxygen, nitrogen, and phosphorus. Same pattern, just one new element. So phosphate, and I didn't build the molecules, but this is what the structure looks like. It's got a -3 charge. Those of you that were in chemistry class with me last year, this is phosphoric acid. If it had no charge on it, you'd see the 3 H's. And that's key because it's when you build a nucleic acid, you're going to take out water, and this is where it's kind of coming from. So just get used to this idea here. So this is what phosphate looks like. Here are your 5-carbon sugars, ribose and deoxyribose. And you don't need to memorize the numbering system, but it is helpful to know that you are counting from right to left around the ring, my right to left. And if you look at the second carbon, ribose has that carbon bonded to 2 other carbons and has an OH below and an H up. Deoxyribose, you're just missing an OH. That's it. So there's nothing special. Okay, but you don't need to memorize this. You're going to be able to see this. But when you have DNA, you're using deoxyribose. When you have RNA, you're using ribose. Okay, but it's a 5-carbon sugar. And then you have these different nitrogen bases. Okay, and you're going to learn the different connections and what goes with what. DNA uses adenine, guanine, thymine, and cytosine. RNA uses adenine, guanine, thymine, and uracil. Cytosine and uracil, excuse me. There's just that one little switch, but it's not a huge deal. So if you look at this, one nucleic acid is put together with a phosphate, a 5-carbon sugar, and a nitrogen base. So as I'm looking at this here, you would have your phosphorus, your 5-carbon sugar, and a nitrogen base. I'm going to go back here for a second. So it's just that one unit here. So you can kind of see how things are going to begin to get linked when you're doing multiples. Phosphorus, sugar, base. So there's a little foreshadowing of how things are going to get connected. Well, if you want to connect below, where are you adding the phosphorus? And what part of the sugar are you going to be connecting to? So let's take a look here. So here you go. So for one nucleic acid, phosphorus connects at the 5-carbon. Here's your sugar. Your base is at the 1-carbon. When you connect to the next unit, connects here at the 3. New phosphorus, 5. Here's your sugar, base. Next phosphorus connects at the 3, links through the 5, sugar, base. And it just repeats over and over and over again. So that's nucleic acids. It's pretty simple. The pattern repeats. So we've done carbohydrates, fats, proteins. Now you've got nucleic acids. See you next time.